Next is question number 3. Write the following sets in roster form. Section 1. A is equal to set of x such that x is an integer and -3 is less than or equal to x less than 7. Solution. There are two conditions mentioned in the question. The first condition is x is an integer, and the second condition is -3 is less than or equal to x less than 7. Consider the number line of integer given below. As per the second condition, -3 is less than or equal to x. This means x can have the integer value -3 and above. So, let's mark -3. Also, it is said that x is less than 7. This means x cannot take 7, and the next integer less than 7 is 6. So let's mark 6. This means x can have all the values from -3 to 6. So, the integer values that x can take are -3, -2, -1, 0, 1, 2, 3, 4, 5, and 6. Therefore, we can write the given set in roster form as A is equal to set of -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Next is section 2 of question 3. B is equal to set of x such that x is a natural number less than 6. Solution. Here, there are two conditions mentioned in the given set. The first condition is x is a natural number, and the second condition is x should be less than 6. Consider the number line of natural numbers as shown. As per the second condition, x should be less than 6. This means x cannot take the value 6 or above, which implies x can have the values 5, 4, 3, 2, and 1. Therefore, we can write the given set as B is equal to set of 1, 2, 3, 4, 5. Next is section 3 of question 3. C is equal to set of x such that x is a two-digit natural number such that the sum of its digits is 8. Solution. Here, there are two conditions mentioned in the given set. The first condition is x is a two-digit natural number, and the second condition is sum of digits of x is equal to 8. The 10 basic numbers in mathematics are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Among these numbers, the pair of digits which gives us the sum equal to 8 are 1 and 7. They make the pairs 17 and 71. 2 and 6. They make the pairs 26 and 62. 3 and 5. They make the pairs 35 and 53. 4. 4 make the pair 44. 8 and 0. They make the pair 80. Therefore, we can write these elements in the form of set to get the roster form of C. That is, C is equal to set of 17, 71, 26, 62, 35, 53, 44, 80. Next is section 4 of question 3. D is equal to set of x such that x is a prime number, which is a divisor of 60. Solution. Here, there are two conditions mentioned in the given set. The first condition is x is a prime number, and the second condition is x is a divisor of 60. Let us first write the divisors of 60. They are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Now, As per the first condition, x should be a prime number. Prime numbers among the divisors of 60 are 2, 3, and 5. Therefore, we can write the given set in roster form as D is equal to set of 2, 3, 5. Next is section 5 of question 3. E is equal to set of all letters of the word trigonometry. Solution. The word given in the question is trigonometry. We know the property that the elements of set cannot repeat. Now, let's take the letters from the word trigonometry without repeating. The letters are T, R, I, G, O, N. No need to write O again. M, E. No need to write T, and R, again. Lastly, Y. Now, let's write the roster form of the given set, using these letters in red. That is, E is equal to set of T, R, I, G, O, N, M, E, Y. Next is section 6 of question 3. F is equal to set of all letters in the word better. Solution. The word mentioned in the question is better. We know, as per the property of sets, elements of set cannot repeat. So, let's take the letters from the word better, without repeating the letters. Which are B, E, T. No need to take T and E again. And lastly, R. Therefore, we can write the given set in roster form as F is equal to set of B, E, T, R.